My name is John, and welcome back to Plane Crashed. Tonight, we're diving into one of aviation's most haunting tragedies, crash that left investigators stunned and pilots around the world questioning how such a thing could even happen. Inter Flight 148 was supposed to be a routine domestic journey through the French skies, but instead, it ended in a devastating collision with the Vosges Mountains. This is not just the story of a crash, it's the story of how confusion, design flaws, and a single tragic misunderstanding turned a routine descent into an unforgettable disaster on the cold evening of January 20th, 1992. As the winter sky over France turned a deep steel gray, Inter Flight 148 prepared to make what should have been a routine domestic flight from Lyon to Strasbourg. The Airbus A320 stood on the tarmac, gleaming under the dim lights of the airport, its engines humming quietly as passengers boarded, unaware that they were stepping into the pages of one of aviation's most haunting tragedies. Inside the cockpit sat Captain Christian Heckett, an experienced pilot with more than 10,000 flight hours, and First Officer Jules Cherubin, a skilled co-pilot with extensive knowledge of the A320. They were both confident, competent, and familiar with their aircraft, a machine widely celebrated as one of the most technologically advanced airliners in the world. The Airbus A320 represented the dawn of a new era in aviation. It was among the first jets to feature a fully digital fly-by-wire system, where computers interpreted pilot inputs rather than mechanical linkages. It also boasted an advanced autopilot and flight management system capable of controlling nearly every phase of flight, from climb to descent. To many, it symbolized the future of safe and efficient flying. Yet, that same sophistication introduced layers of complexity that, under the wrong circumstances, could turn dangerous. As the passengers settled in, the crew prepared their flight plan, carefully entering their route into the flight management computer. Their destination, Strasbourg Airport, was nestled near the Vosges Mountains, surrounded by uneven terrain that demanded precision during the approach. The flight, scheduled to last about an hour, took off smoothly at 6:20 p.m., climbing through the fading light of dusk into the calm upper atmosphere. The initial portion of the journey was uneventful, just another night flight across France. The passengers chatted quietly or rested, the soft rumble of the engines their only reminder that they were moving through the cold, dark sky. But as the aircraft began its descent toward Strasbourg, the environment began to change. Clouds thickened, the night grew darker, and visibility deteriorated rapidly. By the time Flight 148 approached the Vosges region, the aircraft was enveloped in a blanket of fog and drizzle, cutting off all visual contact with the ground below. The cockpit became a world of glowing instruments and screens, with the outside world reduced to nothing but darkness. The approach to Strasbourg was known to be tricky, especially at night and in poor weather. The airport lacked a full instrument landing system, ILS, on the runway they were approaching, which meant the pilots would have to rely on a non-precision approach using the VORDM-ES system that provided directional guidance but no vertical glide path. In essence, the pilots would have to manage their own descent manually or with the help of the aircraft's automation, carefully controlling their altitude and angle of descent to ensure they remained clear of the surrounding mountains. In calm conditions with full visibility, it was manageable. But in heavy fog and rain, the workload increased significantly, and even small errors could become catastrophic. As the Airbus A320 neared the approach fix, Captain Heckett and First Officer Cherubin began configuring the aircraft for descent. They briefed the approach, discussed the altitudes, and began programming the flight control unit, the interface that allowed them to input descent modes and rates into the autopilot. The flight management system offered two main ways to control descent: vertical speed mode, where pilots set a specific rate in feet per minute, and flight path angle mode, where they could set the angle of descent in degrees. The two modes used the same input display, with only a small symbol distinguishing one from the other. It was a clever but potentially dangerous design choice, especially in stressful conditions when quick inputs were needed. The pilots decided to use a descent angle of 3.3 degrees, a typical path for an approach of this kind. They entered 3.3 into the control panel, assuming they had set the aircraft to descend at that angle. What they didn't realize was that the mode selector was still set to vertical speed. The system now interpreted their input as a command to descend at 3,300 feet per minute, a steep and dangerously fast rate for that phase of flight. As the Airbus began its descent, the fog outside grew denser, and the lights of Strasbourg remained invisible. The cockpit displays showed altitude and distance data, but the vertical speed indicator now revealed a rapid descent. The pilots, perhaps believing this was a temporary increase, continued monitoring other parameters, trusting the aircraft's automation to manage the rest. Meanwhile, the autopilot followed the instructions it had been given, lowering the nose and increasing the descent rate as it tracked toward the VOR beacon. With the darkness and clouds concealing the terrain, the crew had no visual cues to indicate the danger they were in. The mountainous region beneath them rose sharply, and their current flight path would intersect it long before they reached the airport. On the radar screen, everything appeared normal. The descent rate, while aggressive, didn't immediately trigger alarm since both pilots believed they were still descending along the correct approach profile. The situation was worsened by the fact that French domestic aircraft at the time were not equipped with the Ground Proximity Warning System, GPWS, a safety device that alerts crews when they are dangerously close to terrain. Inter had argued that such systems could produce unnecessary warnings during their frequent low-level flights, but that decision would prove tragically short-sighted. The weather reports from Strasbourg indicated low visibility and patchy fog, and the air traffic controller on duty cleared Flight 148 for the VORDME approach. The controller's last contact with the aircraft was routine. Nothing seemed out of place. The A320 was descending on schedule, its radio transmissions calm and professional. Inside the cockpit, however, tension was rising. The crew struggled to maintain situational awareness, juggling multiple tasks and trying to keep track of their descent without visual confirmation. The navigation displays provided only abstract information numbers, dials, and indicators, while the true danger lay hidden in the darkness outside. At 6:59 p.m., the Airbus passed 5,000 feet, still descending rapidly. At their current rate, they were dropping toward the mountains at over 50 feet per second. The pilots cross-checked their instruments, perhaps sensing that something felt off, but with no visual references and no GPWS warning, they had no clear reason to believe they were in immediate danger. In moments like these, human factors, fatigue, workload, and trust in technology combine in unpredictable ways. The crew had flown for hours through challenging conditions, relying heavily on automation. Their belief in the aircraft systems, while understandable, dulled the instinctive skepticism that might have prompted a double check of the descent mode. Seconds later, the aircraft's altitude dropped below 4,000 feet. The mountains ahead rose to nearly the same height. The Airbus was now on a collision course with the steep, forested slopes of Mont Sainte-Odile, hidden beneath the thick fog. Some passengers might have noticed a slight increase in the sound of the engines or the sensation of a steeper descent, but most remained unaware, trusting that the flight was proceeding normally. The cockpit voice recorder later revealed calm voices focused professional until the final moments. At 7:04 p.m., the Airbus's altitude dropped below 3,000 feet. The terrain ahead loomed unseen, just seconds away. It was only when the aircraft's lights reflected faintly off the misty slope that the crew realized what was happening. A shout broke through the cockpit. "Pull up!" The pilots yanked back on the side sticks, engines spooling to full power as the aircraft strained to climb. But there was no time. Just moments later, at approximately 2,600 feet, Flight 148 slammed into the forested ridge of Mont Sainte-Odile at nearly 300 kilometers per hour. The left wing struck first, shearing through trees, followed by the fuselage, which disintegrated upon impact. The wreckage scattered across the mountain, lit briefly by the flames of burning fuel before the cold mist extinguished them. Inside the shattered fuselage, a few survivors clung to life amid the wreckage. Against all odds, 33 people out of the 96 on board survived, many of them thrown clear or shielded by debris. For rescuers, reaching the crash site was a nightmare. The thick fog, steep terrain, and remote location meant that it took hours before help could arrive. By the time emergency crews found the site, the survivors were cold, injured, and in shock. The investigation that followed would reveal the heartbreaking simplicity of the error that doomed Flight 148. Investigators from the French Bureau of Inquiry and Analysis BIA reconstructed the sequence of events and discovered that the descent mode selection had caused the aircraft to descend far faster than intended. The difference between entering 3.3 in flight path angle mode and vertical speed mode was just a matter of a small indicator light, a detail easy to miss in a dimly lit cockpit under pressure. Furthermore, the lack of a GPWS meant that no warning was sounded as the aircraft approached terrain. It was a perfect storm of human error, design flaw, and environmental challenge. The A320's automation, meant to enhance safety, had become a silent trap, and the very systems designed to simplify flying had instead created deadly ambiguity. In the aftermath, Airbus modified cockpit displays to better distinguish between descent modes, and France mandated the installation of ground proximity warning systems on all commercial aircraft. The crash of Flight 148 became a case study in the dangers of over-reliance on automation and the need for clear, intuitive cockpit design. But beyond the technical lessons lay a deeper human story, the story of how two skilled pilots, facing an invisible threat on a dark winter night, were led astray not by negligence, but by the limits of trust in the machines they commanded. For the families of those lost, the tragedy left wounds that time could never fully heal. The forest of Mont Sainte-Odile remains a quiet memorial, where the sound of wind through the trees is the only echo of a night when technology, confusion, and fate collided high above the French countryside, bringing one of aviation's most advanced aircraft crashing down from the sky, inside the cockpit of Inter Flight 148. Tension and concentration filled the air as the aircraft continued its descent through the thick fog blanketing the Vosges Mountains. The pilots were entirely reliant on their instruments. The world outside was invisible, a dark expanse of nothingness. Captain Christian Heckett and First Officer Jules Cherubin were both experienced men, their hands steady, their eyes darting between the screens and dials glowing softly in the cockpit. Yet, despite their skill, they were now navigating into a trap that neither could see coming, a trap created not by recklessness or negligence, but by the way technology and human understanding can fatally collide under pressure. The Airbus A320 was a marvel of modern aviation at the time, designed to make flying safer through automation and precision. It featured the latest in digital flight systems, fly-by-wire controls, computer-managed flight modes, and automated descent programs meant to lighten the pilot's workload. But that very sophistication demanded absolute clarity from the crew about what each system was doing. And on this night, that clarity began to blur. The approach into Strasbourg was one of the most complex in France, especially in poor weather. The airport was surrounded by rising terrain and forests, and its lack of a full instrument landing system meant that pilots had to depend on a VORDME approach. Unlike modern ILS systems, which provide both horizontal and vertical guidance, the VORDME only offered lateral navigation. That left vertical control, the rate and angle of descent, entirely up to the pilots. They had to manage their descent profile manually or through the Airbus's automation modes, inputting numbers into the flight control panel that the computer would then follow. Normally that wouldn't be a problem, but under conditions of darkness, fog, and fatigue, even a small misinterpretation could have disastrous consequences. At this point in the flight, the crew had switched off managed descent mode and opted for a more direct, manual control using the autopilot's vertical settings. Their goal was to descend at a safe and steady rate down toward the runway. The captain called for a descent angle of 3.3 degrees, a standard approach path that would allow them to glide safely toward Strasbourg. The first officer entered 3.3 into the flight control unit. Believing that the system was set to flight path, angle mode, meaning the plane would descend along a 3.3-degree slope relative to the horizon. But the system wasn't in that mode. It was still in vertical speed mode. That meant the number 3.3 was now interpreted by the computer as 3,300 feet per minute, a steep and unsafe descent rate. The difference was subtle, so subtle that only a small label on the display distinguished the two modes. It was a design flaw that Airbus engineers later admitted could easily confuse pilots, especially those accustomed to older aircraft with simpler systems. The display that showed the descent value didn't clearly indicate whether the input referred to an angle or a speed. In a quiet, well-lit simulator, the difference might be obvious. But in a real cockpit, late at night, under stress and fatigue, the chance of confusion was dangerously high. As the aircraft began to descend, everything appeared normal. The flight path on the navigation display looked consistent. The autopilot held its course, and the rate of descent didn't immediately seem alarming. To the pilots, who were focusing on navigation fixes and radio calls, there was no obvious sign that anything was wrong. But in reality, the Airbus was dropping faster than it should have been, diving toward the rising terrain ahead. Outside, the forested slopes of Mont Sainte-Odile were hidden in the darkness. The passengers sat unaware, some reading, others resting, feeling only the gentle hum of engines as the aircraft descended. No one could see that the terrain ahead was creeping closer with every passing second. In the cockpit, the workload intensified. The crew had to manage the navigation, communicate with air traffic control, and keep an eye on the weather, all while monitoring the aircraft systems. The controller had cleared them for a visual approach, even though the conditions made that impossible. The fog was so thick that even the bright landing lights couldn't penetrate it. The pilots had to rely entirely on their instruments, yet the instruments themselves were quietly leading them astray. At around 6:58 p.m., the Airbus descended through 6,000 feet. The captain and first officer were expecting to intercept the proper approach path soon, but the vertical speed indicator showed a much steeper descent. The captain may have noticed the rate, but assumed it was a momentary adjustment by the autopilot. Fatigue and workload made it difficult to question every small detail, especially when the aircraft appeared stable. At 6:59, the Airbus was already below 5,000 feet. The terrain ahead, however, rose sharply to nearly that same altitude. The aircraft's instruments provided no warning. French regulations at the time allowed domestic aircraft to fly without a ground proximity warning system, GPWS, which in most planes would have given an alert and automated voice calling out, "Terrain, terrain," or "pull up." Without that safeguard, the only thing standing between the aircraft and the mountain was the crew's situational awareness, which was now compromised by the confusion over the descent mode. The fog outside was absolute. There were no city lights, no stars, no ground features, just endless gray. The pilots, both trusting the automation, continued following their instruments, believing they were on the correct approach path. But below them, the dark forest of Mont Sainte-Odile was drawing closer, trees reaching up through the mist. The aircraft's descent rate remained high, around 3,000 feet per minute, nearly double what was safe for the approach. The flight data recorder later showed that at this point, the captain briefly adjusted the vertical speed, perhaps noticing something odd, but it was too late to correct the trajectory entirely. In the cabin, passengers began to feel the slight increase in downward force as the aircraft continued descending rapidly. A few might have sensed that something felt off, but most trusted the calm professionalism of the crew and the advanced technology of the Airbus. After all, this was supposed to be one of the safest airliners ever built. At 7 p.m., the aircraft leveled briefly at around 4,300 feet before continuing its descent. The crew was likely expecting to see the lights of Strasbourg below them, but the city was still hidden behind the clouds and terrain. They didn't realize that they were already too low and too far from the airport. The approach chart would have shown minimum altitudes at specific points, but amid the confusion and fatigue, the crew may have misjudged their position relative to the terrain. The instruments offered no terrain mapping, and the radar altimeter, which measures the height above ground, wouldn't begin to warn them until it was already too late. Then, just after 7:04 p.m., the Airbus descended below 3,000 feet. The mountain ahead rose to 2,600 feet. At this point, the ground was less than 20 seconds away. Inside the cockpit, both pilots likely still believed they were safely on approach. But suddenly, something changed. Perhaps the first officer saw the radar altimeter ticking down rapidly, or maybe the captain caught a glimpse of the terrain lights flickering through the mist. A warning tone sounded, a subtle altitude alert, and in that instant, they realized the truth. "Pull up," came the shout in the cockpit. Both pilots grabbed the side sticks, hauling them back in a desperate attempt to climb. The engines roared to full power as the aircraft's nose pitched upward. But physics offered no mercy. The distance between the Airbus and the ground was simply too short. At approximately 7:05 p.m., the left wing of Flight 148 clipped the tops of trees on Mont Sainte-Odile. The aircraft, still traveling at over 300 kilometers per hour, slammed into the wooded slope. The fuselage broke apart violently, scattering wreckage and igniting fires in the cold, wet night. In the chaos, the lights of the cockpit flickered out, and the once steady hum of the engines was replaced by the crack of tearing metal and breaking trees. For those inside, the impact was instant and catastrophic. The front of the aircraft disintegrated,